According to research by Gartner, only 20% of analytics insights will deliver business outcomes in 2022. That is because businesses are not building high-quality predictive models. But what are the possibilities of clean data? And how does boosting models and machine learning play a role? We will present all of this in today's video. Let us get started. Boosting machine learning grants power to machine learning models to improve their prediction accuracy. Boosting refers to algorithms that convert weak learners to strong learners. For example, what classifies an email as spam? The weaker learning approach is to tabulate 3 indicators of spam. So if the email has only a promotional image, link, or starting sentence like "you won a prize," it is spam. However, if the email came from an official domain or is from a known source, then it is not spam. The problem is that these are not definite and accurate when classifying spam. An email body starting with "you have won a prize" could be crucial. Therefore, instead of basing the rule on individual predictions, boosting uses the majority rule or the weighted average of the combined rules. Thus, boosting combines the prediction of each weaker learner to promote a high method of projection. This model is prevalent in data science contests. The linear approach is the most common. The single unit combination of weaker learners is effective for classification and regression. We will present more on this later in the video. Meanwhile, boosting is an ensemble learning technique in machine learning techniques. Ensemble learning is the process of enhancing the performance of a machine learning model by combining several learners. Ensemble learning improves efficiency and accuracy in predictions. For instance, Netflix recommendations are based on the combined prediction of one's history, current search, and locality. If they used only one of these, many suggestions or recommendations would be poor, and you would miss seeing things that would really match your tastes, thus reducing your engagement and ultimately being less beneficial to the company. So the principle is to generate multiple weak learners and combine them for a stronger recommendation. The predictions are more accurate when they are connected. As Michael Schulman, head of machine learning at Kensho, once said, since most of the world's data is unstructured, an ability to analyze and act on it presents a big opportunity. There are 3 types of engines to perform boosting. XGboost is the most advanced one. Adaptive boosting, also known as AdaBoost, and gradient tree boosting also exists. AdaBoost. Adaptive boosting is implemented when combining several weak learners into a single strong learner. The weaker learners in the process take a single input feature and draw a single split decision. The first split decision is classified as the decision stump. When the data analyzed from the first decision stump are wrongly classified, they are assigned to a higher weight. Then, a new decision stump is drawn with considerations from the errors and higher weights. The cycle continues until the problems are all resolved. The AdaBoost strategy is often used for classification, although it can be used for regression. Gradient boosting. This model is based on sequential ensemble learning. The generated base learners are always more effective than the previous one. The overall model improves significantly with each iteration. The errors in the last iteration are improved upon to reduce the loss function. As such, the weights for misclassification outcomes are regulated through an additive model system. Using the additive model trails all the cost functions, which can benefit the learners. For those who do not know, a cost function determines how well or badly a machine learning model performs for a given set of data. Usually, it estimates all the errors in a predicted outcome. On the flip side, some positive traits like sequential improvements could lead to bottlenecks when you need the machine to scale up. We will present more on this shortly. XGboost. This final one is an advanced version of the gradient boosting method. The letter represents extreme gradient boosting. This model falls under the machine learning community. XGboost, developed by Tianqi Shen, aims to increase the speed and efficiency of computing. Shen is an assistant in the machine learning departments and computer science departments at Carnegie Mellon University. Since the gradient version analyzes data sequentially, it might be a little slow. Therefore, the XGboost powers the performance by extreme levels. It designs parallel trees while focusing on both computational speed and model efficiency. It also implements cache optimization to make the best use of resources. This method is always preferred due to its prediction capacity and methods to curb overfitting. The predictions and interpretations are equally easy to handle. However, it can be sensitive to outliers. There is always a but. All the classifiers have to fix the errors in their predecessors. Hence, scaling up could be a problem. Every estimator bases its correctness on the previous predictors, which means the procedure cannot be streamlined. To illustrate, how do I include a new learner to optimize newer suggestions? The entire system must be scrapped and a newer one reinstated to do that. That could be tedious for the human intervention each time an upscaling is necessary. In spite of this, Boosting is an excellent tool to modify machine learning knowledge. Here is another video that you will enjoy. What is unsupervised learning? Machine learning tutorial.